Hello class, this is a continuation of factorization of algebraic groups. In the last video, which is literally up here, in the last video we saw that we could factor out a common numeric factor. So these are all numbers that we factor out. So 2 is taken out, 5 is taken out, 6, -2, and so on. In this one we're going to show that it's possible to factor out letters, or in this case common pronumerals, from algebraic expressions. Let's get straight into it. Let's take a look at this expression, PQ plus PR. That's a bit messy, but stick with it. That's an R. Well, just like in the previous video with numbers, we can factor out numbers that are common to both of them. So what is common to both PQ and PR? Well, P is, so P is going to be on the outside. P times what gets me PQ? Well, Q does, because P times Q is PQ. Plus P times what gets me PR? Well, R does. So notice how it's possible to, if there's a letter that's common to both of them, we can factor it out. Okay, so now let's take a look at the next example. Example B is going to be 6mn minus 4m. On this one, we're going to actually combine both. The thing that we learned in the previous video in factoring numbers. Is there a common factor between 6 and 4? Yes, there is. 2. Is there a common factor between the letters? Is there an M and an M? Yes, look, take a look. There is. So 2m on the outside. 2m times what gets me 6mn? Well, we'll focus on the numbers first. 2 times what gets me 6? Well, it's going to be 3. We already have the m. No need for that. We need an n, so there it is. Take a look. 2 times 3 is 6. M times n gets mn, so this works out. So now all we need is for this to become -4m. So 2, I know that 2 times 2 gets me 4. M times, well, we don't need a letter, so that's going to be it. All we need now is a symbol. I need this to be a negative. That's a positive. Well, which means that this must be a negative, because 2 times -2 is -4m. Now, let's get slightly more complicated now. If we have, question C is 12k squared plus 8k. Okay, so for this one, what is the biggest common factor to 12 and 8? You got it yet? It's going to be 4. Now, is there a common letter for both of them? Well, this one has 2, this one has 1k, so it's going to be k. 4 times what gets me 12? Well, it's going to be 4 times 3. Now take a look. This is k squared, which means there are 2 k's there. Well, if there's 2 there, there's only 1 here. I need 1 more, don't I? Alright. So 4 times what gets me 8. Well, it's going to be a plus 2, because 4 times positive 2 is positive 8. There's a k here, but we already have a k, so that's the end of that expression. Now let's go jump to the deep end now. This is still continuing. So let's take a look at last two. So that's that was C, the last one. So let's question D. It's going to be 7a cubed plus 21a to the power of 5. Okay. So what is the biggest number and letter that we can take from both? Well, 7 and 21 are multiples of 7, so it's going to be 7. Now take a look here. This one has 3, and this one has 5. So what's the biggest one we can take out? Well, it's all of this. That's going to be a little tricky, but hang on there. It's actually going to take out all of it. Here's where it gets a little bit trippy. 7a cubed times what gets me 7a cubed? Well, isn't that itself? Well, wouldn't that just be 1? Because this 7a cubed times 1 gets me 7a cubed. So that's going to be 1. Plus 7 times what gets me 21? Well, it's going to be 7 times 3. 7 times 3 is 21. This has 3. I need 5. So I actually need to multiply it by 2 more, because these will add. So that is our factorization of this expression. So this has been factorized into this one. We'll do one last one just to really get our head around it. And I'll give you a moment to actually give it a go. This is last one. E is going to be 15p squared q cubed minus 12 p q to the power of 4. Okay, so this has multiple things going on, but let's just break it down slowly, one at a time. We'll focus on the numbers first. 15 and 12. What's the biggest number we can take from 15 and 12? Well, it's going to be 3. P squared, and P, which is 1. This has an index of 1 that's secretly there. Actually, I'll draw it up in for you just in case you don't know what I'm talking about. That has a indice or an index of 1. It's just not written, but I wrote it in for you. What's the biggest P we can take from both of these terms? Well, it can't be P2 because that one's missing 1. So the biggest one we can actually take is just P. What's the biggest Q we can take from 3 and 4? Well, if this has 3 and that has 4, I can take at most 3. That's Q3. Okay. 3 times what gets me 15? Well, that's going to be 5. P times what gets me P squared? Well, I need one more P. Q times what gets me Q cubed? Well, that's already there. We don't need to put a 1 because this is going to multiply with this to give that expression anyway. So this is the factorization. We're done with this section. So now let's move on. 3 times what gets me 12. Well, I know 3 times 4 is 12, but I need it to be a negative. That's a positive. That 3 is a positive, so this is going to be a negative. Because look, 3 times negative 4, negative 12, that works. This has 1p. We already have 1, so we don't need it. This has q4, so there are 4 of them. This one only has 3, so we need 1 more. So we put a q there, and that there's the factorization of common pronumerals, and we've actually combined everything together. Best of luck.